And now we continue with the last report for this panel. Наш последен панелист е доцент Надежда Зудилина с темата и Платоновата диереза в републиката, в държавата, извинявайте, като метод за представяне на фрактала на битието, самоподобен по дълбочинната ос. Plato's diaeresis in the Republic as a method of representing the fractal of being, self-similar along the depth axis. Floor is yours, dear Dr. Zudilina.
Dear colleagues, thank you very much. The theme of my report, it's Plato's diaeresis in the Republic as a method of representing the fractal of being, self-similar along the depth axis. So, yes, okay. This is problem with, okay. Diaeresis is a kind of iteration, a self-similar in the same proportion, repeated division on two. Therefore, the result of diaeresis is a self-similar object. Here you can see picture from Herman Weil's book. He gave the scheme of diaeresis. You can see the first upper level, which symbolizing the one, and after that the rest levels, which created by division on two. You can see exponential growth of number of these sections. Self-similarity is a property of an object or process to exactly or approximately coincided, coincided with a part or one of the phases or of itself. That is, the object or process as a whole has the same shape or characteristics as one or more from its parts or phases. Here you can see this process of iteration, or repetition, the same procedure. Triangle, which is multiplying by iteration. This is so-called Sierpinski triangle. This is the final stage of this self-similar object. Let's consider what is the fractal. Fractal is an object or process that has the property of self-similarity. As Benoit Mandelbrot, the founder of fractal theory, explains, many fractals are self-similar, that is, they are structures in which each part is the same as the whole, only smaller. Here you can see the famous Mandelbrot set, the part of this fractal. But fractals can be also natural objects. And if the mathematical fractals are exact fractal with exact self-similarity, natural fractals are objects with approximate self-similarity. Mathematical fractals, including geometric ones, such as Sierpinski triangle, often have namely exact self-similarity, while physical fractals, such as clouds, mountains, the distribution of trees in a forest, some plants, or even human nervous or circulatory system, etc., have an approximate self-similarity. On the picture, you can see fractal form of broccoli romanesca. And here, one more example of natural fractal, fern leaf. And here you can see the mathematical modeling of this fractal of fern leaf. Since the fern leaf is another example of natural fractal, its fractal form can be reproduced mathematically using so-called an iterating function system, IFS. The picture shows 4 states of fractal development during iterations. And one more example of natural fractal. This is a diffusion limited aggregation, so-called DLA. Then when copper aggregate formed in an electrodisposition cell. But natural fractals are not simply fractals. They are so-called multifractals because they are complex fractals in homogeneous objects, different regions of which have different fractal properties. It is not enough to introduce just a single exponent, the so-called the fractal dimension D, for the full description of such multifractals, of its dynamics of development. A continuous spectrum of such exponents is needed, the number of which is in reality infinite even. And now let's consider the divided line in Plato's dialogue Republic, because my thesis that divided line in Plato's Republic is a fractal. As we have already seen with the example of the Sierpinski triangle, fractals obtained as a result of repetition, of iteration of the same procedure or algorithm. Since the diaeresis of the line in Plato's dialogue The Republic is a repetition of the division into unequal segments, the divided line resulting from the division is a fractal. You can see it on the picture. Although the one itself, this is upper line, as a whole is not divided at the highest or deepest level, its first division at the underlying level is self-similarly repeated at subsequent underlying levels. Plato describes 2 levels of line division. On the picture, a 3rd level of division has been added, which is an extrapolation of the diaeresis principle, since from mathematical point of view, the number of division levels of a line can be infinite. I mean the division of line in the book 6 of the Republic. Description of the diaeresis of line in Plato's dialogue The Republic you can see here, but we have no much time, so I underline only main points. Plato told about a line divided into unequal sections and cut each section again in the same ratio. And the first is the visible, and the second, the intelligible order. And after that, he explained that one part of this division is shadows and then reflection in water, and so on. And the other part is animals, plants, and the whole class of objects made by man. And after that, the section of the intelligible consists of images, assumption from which it proceeds not up to the first principle, but down to a conclusion. While is another section in which it advances from its assumption to a beginning or principle that transcends assumption, and in which it makes no use of the images employed by the other section, relying on ideas only, and progressing systematically through ideas. Here you can see these 4 sections, and the main division into the divisible and the intelligible. And let's consider now the hierarchy of images, which we can find in Plato's doctrine. For Plato, physical bodies are also images that are reproductions of their prototype eidos. Eidos is the original. A copy of the original can be either an icon, a true likeness, that is, it corresponds to the original, eidos, or an eidolon, phantasm, an apparent seeming likeness, that is, it does not correspond to the original, eidos. Thus, according to Plato, there is the following hierarchy of similarities, from the highest to the lowest level: eidos, eikon, and eidolon. On the example of a man, this is the prototype of man, the eidos of man, the physical body of man, or an icon of the eidos, and reflection of the human body in a mirror or water, etc. That is eidolon of the eidos. In the hierarchy of the fractal of being, there is a cascade of copies of the original. Therefore, in a relative sense, it can be said that, for example, for the reflection of the human body in water, the original is the physical body of man. However, in the absolute ultimate sense, the original for the reflection of the human body in water is the main sample or the main prototype, the eidos of man. And now let me refer to one of the researchers of phenomenology of images, Lambert Wiesing, German philosopher, who investigates the concealed canon of Plato. Mimesis, he says, or imitation, is a genus. It corresponds to a wide concept of imitation. This means that at least two different phenomena fall under the concept of mimesis or imitation. On the one hand, the phenomenon of imitation by depiction, and on the other, the phenomenon of imitation by copying or replication. Compare, for example, a photo and a copy or replica of a watch. The relation of resemblance in each case is fundamentally different. In both cases, we are dealing with the imitation of a watch, but only the replica tries to be that which it imitates. This is precisely what is essential to copies or replicas. They lead to the reproduction of objects that are regarded by the viewer as examples of the kinds of objects they imitate. The copy tries by means of material resemblance to duplicate an object in its very existence. Depiction is concerned with creating an object on which an image object appears for the viewer, an image object that in physical sense is not present at all. So, for Plato, not only the accuracy of reproducing the appearance of an object is important, but more importantly, if we express Plato's idea in modern language, the correspondence of the number of dimensions of a copy to the number of dimensions of the original. Plato explains that is the true likeness-making art, eikastike, in the Dialogue Sophist. This is met with, as a rule, whenever anyone produces the imitation by following the proportions of the original in length, breadth, and depth, and giving, besides, appropriate colors to each part. The results of this kind of art, of imitation, are icons. The creation of appearances or seeming likeness, Plato calls the fantastic art, or fantastike. And to the art which produces appearance, he said, but not likeness, the most correct name we could give would be fantastic art. The result of this kind of art of imitation are phantasms or idols, or Greek phantasma or eidolon.
2 minutes left.
Icons.
2 minutes.
Okay, thank you very much.
Thank you.
Icons are copies of the original in which the number of dimensions is equal to the number of dimensions of the original. If the number of dimensions corresponds to the original, then the similarity is true, and this similarity is a con. If the number of dimensions in the copy is less than in the original, then the similarity is seeming, and this similarity is eidolon. For example, a two-dimensional reflection of a three-dimensional human body. In general, the more the number of dimensions corresponds to the original, the truer the similarity is. Therefore, a sculpture of a man is better than a picture of this man. Thus, Plato's hierarchy images, which is the fractal of being, is built on the basis of the number of dimensions. Indeed, in Plato's doctrine, the one is the point, or the zero-dimensional, which is under special conditions can be considered as the infinite dimensional. The dyad is the line, or one-dimensional. The triad is the plane, the two-dimensional or triangle. And the tetractys is the three-dimensional body, or pyramid. Here you can see this scheme of diaeresis with indication of degrees of exponentiation on the left side of this picture. As Hermann Weyls explains, by means of the Platonic diagram, which is identical with the division net of the one-dimensional continuum, Plato assigns their places to all beings by proceeding from the general to the specific by bipartition or diaeresis. Along what axis do we move when we divide a line or a piece of matter? To answer this question, let us turn to the work Isotov and Mavrikidi, Fractals, Divisibility of Matter as a Degree of Freedom in Material Science. These authors, on the basis of the results obtained by Otto Hölder, who distinguished two ways of the representation of measurements by addition or extensively and by multiplication or intensively, they introduce, in addition to the three extensive spatial axis, length, width, height, one more intensive spatial informational axis, which they call axis of the divisibility of matter. I will call this axis, by analogy with other spatial axes, as the depth axis. Due to divisibility, the structure of matter is hierarchical. The language of fractals is universal. Any object can be represented as a fractal volume. The axis of depth arises when moving deep into matter by dividing it, for example, from molecules to atoms, subatomic particles, and field. In the 3D world, the depth axis is the fourth spatial axis, which is logically orthogonal to the three spatial axes. To simplify, we can represent three axes taken together as one axis, which in 3D world is the extensiveness axis, while the axis which is orthogonal to the extensiveness axis we can represent as intensiveness axis. That is, in three-dimensional world, the depth axis. 3 dimensions of the extensiveness axis make it possible to display the external size of the object, and the fourth axis, the depth axis, the internal structure of the object. Let's return to the Hermann Weyls scheme of diaeresis and pay attention to the fact that in the upper level, next to the digit 1, symbolizing the 1, there is a mathematical symbol of the perpendicular. This coincides with the position stated in this report that the intensiveness axis represented in the three-dimensional world by the depth axis is located orthogonally or perpendicularly to the three extensive axes. And the last slide.
Zudilina, just a few sentences, please.
Oh, okay.
In order to have some time for discussion. Thank you for your understanding.
So you can see my last slide. The main point here that depth axis has information material binarity. because in this axis meet physics and computer science meet, because movement along it is both material and symbolic. That is, changes in size are accompanied by changes in properties. And perhaps this is not only movement from the dense matter to the field, but also from the mental, from the bodily, to the mental. That's all. Thank you very much, and thank you for your attention.
Thank you very much for this interesting presentation.
Thank you too. Thank you very much.
We have a colleague in Bulgaria, a mathematician and a philosopher, Lazar Tomov, who is dealing with the bifurcation systems in Plato's dialogues.